Hey everyone, welcome to Module 1. I'm really glad you're here, because this is where the whole course starts. Now, I know some of you signed up for this class because, well, you have to. And statistics has a bit of a reputation. It can sound dry, intimidating, or like it's all about memorizing formulas. So, let me put your mind at ease right away. That's not what this course is about. Here's what I actually want to happen. By the end of this module, I want you to be able to look at a headline, a product review, or maybe a poll you see on the news. And instead of just accepting the number in front of you, I want a little voice in your head to say, wait, where did that number come from? Can I trust it? That instinct? That's statistical thinking. And that's the real skill we're going to build throughout this course. So today, we're going to start with why data matters. We'll learn some of the basic vocabulary of statistics. We'll look at how studies are designed, how researchers decide who to study, and some of the ways studies can accidentally or sometimes intentionally mislead us. And finally, we'll talk about something that's extremely important whenever we work with data about real people. Ethics. All right, let's dive in. Okay, before we get into the material, let me quickly show you the roadmap for the whole module. I like doing this because it helps to know where we're headed before we start. We begin in section 1.1 with a simple question: why does statistics even matter? And instead of just telling you that it's important, I'm going to use 2 true stories to show you why. Then, in section 1.2, we learn the language of statistics. We'll talk about types of data and levels of measurement. Think of this as the vocabulary that everything else in the course will build on. In section 1.3, we look at how a good experiment is designed and what has to happen for an experiment to actually prove something. Then, in section 1.4, we'll talk about different kinds of studies, along with the main ways researchers choose a sample of people to study. In section 1.5, we get into bias and confounding. These are some of the sneaky ways a study can give us a misleading result, even when everything looks convincing at first. And finally, in section 1.6, we finish with ethics, because at the end of the day, every data point represents a real person. Now, here's the one thing I want you to keep in mind as we go through this module. Each section builds on the one before it. This isn't just a list of random topics. Think of it like a staircase. Each step helps you get to the next one. So as much as possible, try not to skip steps. All right. Let's start with the big question. Why should you care about statistics at all? I could just tell you, statistics is useful, and move on. But let's be real, that probably wouldn't convince anybody. So instead, I want to tell you 2 true stories. One of them is a tragedy. The other helped save a lot of lives. And even though these stories are very different, they both come down to the same thing: statistics. Okay, let's take a look at our first story. On January 28th, 1986, the Space Shuttle Challenger launched, and just 73 seconds later, it broke apart. All 7 crew members were killed. Many of you have probably seen the footage before. But here's the part I really want you to focus on, because this is where the statistics lesson comes in. This wasn't only a mechanical failure. It was also a failure to properly analyze data and to communicate what that data was telling us. Let me explain. The shuttle's rocket boosters were sealed using rubber rings called O-rings. And before the Challenger launch, engineers had already noticed something important. When temperatures dropped, those rubber O-rings became stiffer and less flexible. And when they became too stiff, they didn't seal as effectively. In other words, there was a pattern in the data. Lower temperatures were connected to a greater risk of O-ring failure. So the information was there. The problem was that it wasn't communicated clearly enough to the people making the final decision, and the warning wasn't taken seriously enough. On the morning of the launch, the temperature was about 36 degrees Fahrenheit. That was colder than any previous shuttle launch. The O-rings failed, and the Challenger was lost. So here's the lesson I want you to remember. Having data is not enough. You have to analyze it correctly. You have to communicate it clearly. And then you have to act on what the data is telling you. 7 people died in part because important statistical evidence was not given the weight it deserved. And I start with this story on purpose because I want you to see that statistics is not just something we do in a classroom. It isn't just formulas, graphs, and homework problems. Sometimes, understanding the data correctly can literally be a matter of life and death. Now let me tell you a story that goes in the opposite direction, where good statistical thinking actually helped save lives. This story takes us back to World War II. The military wanted to add armor to their bomber planes to protect them from enemy fire, but there was a problem. You can't just cover the entire plane in armor, because then the aircraft becomes too heavy to fly effectively. So they had to be strategic about where that armor went. And at first, they did something that seems completely logical. They looked at the bomber planes that returned from missions and mapped out where the bullet holes were. Most of the damage appeared on the wings, the tail, and the main body of the plane. So the obvious conclusion was, put more armor where you see the most damage. Now, before I tell you what happened next, I want you to think about that for a second. Look at the 2 panels on this slide. On the left, you see the obvious answer. Reinforce the areas where the bullet holes are. Does that logic actually hold up? Take a moment and think about it. Okay, here's where it gets really interesting. A statistician named Abraham Wald looked at the same data and said, hold on, you're only looking at the planes that came back. These planes are the survivors. If a plane returned safely with bullet holes in its wings, that tells us something important. A plane can get hit in the wings and still make it home. So strangely enough, the wings may actually be one of the safer places to get hit. But what about the planes that were hit in the engines or in the cockpit? They aren't showing up in your data at all. Why? Because many of those planes never came back. They crashed. So Wald realized that the armor should go where there were fewer bullet holes on the surviving planes, because those were the areas where a hit was much more likely to be deadly. This idea has a name. It's called survivorship bias. And the key lesson is this. Sometimes the most important data is the data you don't see. And this idea shows up everywhere in real life. You hear about the college dropout who became a billionaire, but you don't hear nearly as much about the thousands of people who dropped out and struggled afterward. You see the miracle diet success story, but you don't see everyone who tried the same thing and got no result. So here's the habit I want you to start building. Whenever you look at data, ask yourself, what am I not seeing? Who is missing from this data? And sometimes those missing cases tell you more than the ones right in front of you. Now, let's bring this a lot closer to your actual life. Because statistics isn't just about space shuttles or World War II. It's in your pocket right now. Take a look at some of the numbers on the screen. 87% of employees worldwide are not engaged at work. The average person checks their phone about 58 times a day. About 1/3 of college graduates end up working in a field that's completely unrelated to their major. 40% of adults say they don't get enough sleep during the week. 70% of Americans believe AI is going to take over a lot of jobs in the next 50 years. And only about 8% of people actually keep their New Year's resolutions. Now, every one of those is a statistic. And numbers like these can shape the way we think about ourselves and the way we think about the world around us. In fact, you probably came across 3 or 4 statistics like these before you even got to class today. Maybe on your phone, maybe on social media, maybe in a news story, maybe in an advertisement. So here's my point. When you see a number like that, I want you to develop the habit of asking, where did this number come from? How was it measured? And should I actually believe it? That ability has a name. It's called statistical literacy. And more than any single formula, that's what this course is really about. So as we move through the course, try not to think of statistics as just another math class. Think of it as learning how to read the world around you with a little more curiosity and a little more skepticism.